What's up guys, Reese here from Stoic Pool, and this is the last video in our testing module, and in this module we're going to be having a look at tracing. Let's get into it. Okay, so traces are really handy for debugging. They're also good to show the paths of validation or just to print some information if you want it for your tests. And we're not going to be doing anything complicated with tracing, but we're just going to have a little look at how to use it so that you can apply it to whatever purposes you have while you're writing your own validators. So if we have a little look at the standard library, the way traces work is with this module called string. Now, I've already mentioned this, but Plutus doesn't recognize strings. Strings instead are represented as byte arrays. And so the string module in the standard library isn't the byte array module. It's not for validators, it's specifically for tracing so that we can print strings. And you can see here that we prefix strings with this @. So where we previously had like the hash with the quotes for our test to make a hex byte array, here we're going to be using @ and the quotes to make a string. And you can see here there's only a handful of functions that we have. We got concat, which is what we're going to be using. And also we got from byte array, from int, and join. Now concat is really the most important one because we can just print any string that we want, but often when we're debugging we want to add some info as well, obviously, right? Info specifically from the validator. If we have a look at concat here, you can see that concat takes two strings and it sticks them together. It concatenates them, right? That's what that word means. So it returns a single string, and you can see this hello world example that demonstrates it perfectly. So how do we use that in our validators? First off, we're going to use Aiken primitive string. And then at the top of our validator, we're just going to say trace as the keyword for tracing at spending UTXO. All right, and this @ quotes is our string, obviously. I know I've already explained that, but just to remind you. So this is just going to trace this string as soon as the validation function, the spend purpose, is triggered. And if we go over to our terminal, we can run Aiken check, and you can see for each of our tests, it says spending UTXO, and it's got this with traces. So that's the basic version of what tracing is, but I mean, it's kind of pointless, right? Just having spending UTXO. So what we're going to do is we're going to have a different trace for each of our redeemer cases. We're going to start with market buy, and before the last call, like the last check, we're going to write trace string.concat, and then we're going to say buying asset for, and then string from int, which turns an integer into a string. And we're going to add our assets dot Lovelace of payment value. So this is the value from our payment output. Remember, in our check just above, you can say expect some payment, and that's because we're looking for a payment to our seller. So it's going to print the value that's going to that seller, and it should match the datum. So if we run Aiken check, then you can see at the top, it says for our first test for market buy, which is the buy redeemer case, obviously, it says spending UTXO, and now it has this extra trace which says buying asset for 200, which, if you remember to our first market buy test, we're charging 200 Lovelace for this asset, which obviously is like nothing, you know, in it would be ADA probably, but yeah, to save the amount of zeros we'd need for that, we'll just put 200. Now, we can also do the same for the other redeemer cases, so that's what we're going to do now. And we're just going to go down the list, so edit is next, and we're going to copy our trace, and then we're going to change it to editing price to, and then instead of the payment value, we're going to have our new datum.price. So this will show the price that we're updating the price to, right, from our redeemer case, and we're checking it against our new datum. And this is good because if we're running our test and the value that we're updating the datum to is wrong, it'll print that, right? Then the last one is delist, and for delist, we're just going to say delisting asset. And you can see here where we run Aiken check, we've got our editing price to 250 for our market edit trace. And we've got our market delist saying delisting asset, and our market delist fail also showing delisting asset. Now, that's not the only kind of tracing that we have. We can also trace specific functions or checks. Normally ones that return a bool, because otherwise it won't know what to print. But for example, at the bottom of our delist fail test, we can just put this question mark at the end of our validation function. And when we print it, it will show market.market.spend. It'll show that function call with a question mark, and it'll just say false. And so this basically is showing you what function failed or what check failed. Now, it's not particularly verbose, like it doesn't give you much information in this case, and that's just because there's only one check, and that's list. We're just checking for the extra signatory, unless you've done your homework, in which case it might have printed something a little bit more informative. But what we can do is we can actually use that in our validator as well. So any of these functions that returns a bool, like list.has, for example, we can stick a question mark there. And because that is the check that fails, it also prints that. Now, again, this is kind of useless at this stage because there's only one check. But when we have loads and loads of checks, it's really handy to just be able to do certain things like that. And if you just put your question mark at the end of the function validator, but one of your expect calls, so like where you have expect some input has blah, 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 blah. If you put the question mark at the end of your function call for your test, it will print that expect that fails. So you know, if you do this and you've got a load of expect checks and it's just printing the function at the end, then you know that it's one of your and cases at the bottom. Remember, and this, and that, and that, and that. So you know it's one of them. If it's one of your expects, it will print your expect. And sorry if I've just not shown you that and just kind of high leveled it for you, but we will see that in action in the next couple of modules anyway, so we can look at it in more detail then. Okay, so now we've got some little traces done and we've had a little look at how that works. Try and apply them to your own validators. Try and use them. They're a debugging tool. You don't want them running in your actual validators when you compile them, and they won't really include them, and it will add a little bit of overhead to your benchmarking as well, to like the output of those tests. But for the sake of finding problems in your validators, like if you're testing stuff and it's not working, add a bunch of traces where you think there might be problems, or try and put traces in strategic places like at the end of your validator call in your test to see if it prints out something that you can address very easily. All right, so a couple of little hints at how you can use that for yourself. It is a useful tool. It doesn't necessarily get used a lot, but when you need it, it is so helpful. It's really, really good to use when it's needed. Okay, cool. That's it for the testing module. Hopefully you did your homework that I gave you at the start of this module for adding the extra check to your validation. And so what I want you to do is write a bunch of failing tests for the other two redeemer cases and see if you can find holes in the validators. I'm not really going to give you any hints at how you can look for potential exploits, but writing a failing test is a good way of discovering them yourself. Okay, that's it for this module. In the next module, we're going to be having a look at building an Oracle validator. I'll see you then.